I am actually recording this as I speak, but feel free to interrupt me if you'd like. No big deal. I could always pause and start back right where I left off. So please let me know if you need me to repeat something or if you have a question. Don't feel that you can't talk right now because I'm recording. Anyway, this is the second day on adding, subtracting, and multiplying and dividing, and we're going to focus in today on multiplying and dividing fractions and also exponents. So let's begin by reviewing what we learned yesterday. Yesterday we learned how to multiply fractions. So let's just jot down this multiplication problem, 3/4, just to review, times 5/6. Okay, 3/4 times 5/6. And what did we learn yesterday? How do we actually do this? Yeah, multiply the numerators, top with top, and the denominators, bottom with bottom. And we're going to get an answer. 3 times 5 is 15. 4 times 6 is 24. And there's your answer, but you're supposed to try to reduce the answer. So 15 over 24, could we reduce by anything? Could we by 3, right? And it's pretty simple. You could try reducing by 2, it won't work. But both top and bottom could be reduced by 3. So you could reduce both top and bottom by 3, and it'll give you your final answer, 5 over 8, 5/8. You remember from yesterday? Are we good? Okay, good. We also said yesterday that you didn't have to multiply first and then reduce. You could have reduced first and then multiplied. So let me show that option. Same problem, 3/4 times 5/6, right? Now we know that 3 over 4, you can't reduce it. You can't reduce by 2, can't reduce by 3. 5/6, you can't reduce by 2, can't reduce by 3, can't reduce. However, the 3 on top and the 6 on the bottom, those could be reduced by 3. So if you want, you could reduce first and then multiply. So I am going to reduce 3 divided by 3 is 1, 6 divided by 3 is 2, and then now you could multiply top with top, that would be a 5, bottom with bottom, 4 times 2, that would be an 8. And what do we have? We have the same answer as we did previously. It's just done a slightly different way. So sometimes it really is more advantageous to reduce first and then multiply, okay? Sometimes. So keep that in mind. Anyway, we understand that, and I hope we all remember that from yesterday. Right now, what I would like to do is divide fractions. So everybody jot down same fraction, 3/4, but let's put divided by 5/6. Okay, 3/4 divided by 5/6. Actually get that out of the way, move this up here. And there's two things that you have to do. The first thing is to change the division to multiplication. So this division right here, I want to change to a multiplication dot. And the second thing is flip the second fraction. Okay, so we're going to change the division to multiplication, and we are going to flip the second fraction. The first one's going to stay exactly the way it is, 3/4. The second one will change to a 6 over 5 instead of a 5 over 6. And then from there, it's just multiplying, right? Multiply top with the top, bottom with the bottom, or you could reduce first and then multiply. It's totally up to you. Do you guys want to multiply first, then reduce, or reduce first, then multiply? What do you say? Reduce first? Sounds good. Now, I know 3/4 you can't reduce, but how about 3 over 5? Could I reduce that, 3 over 5? No. How about 6 and 4? Could I reduce 6 and 4? Yeah, I could, right? By 2. There you go. So let's actually reduce 4 by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. So we have reduced first, and now we're going to multiply. 3 times 3 is 9. 2 times 5 is 10. Voila, there's our answer, 9/10. So 3/4 divided by 5/6 is 9/10. Get it? Cool. All right, so we could actually go to our handout now. And as you can see on this handout, it has the same rules that we covered yesterday. It has the rules on adding and subtracting, which I don't even think of the rules. I always just think of money, right? And it does have the rules for multiplying. And that, all you got to remember is the signs are the same, then the answer is positive. If the signs are different, then the answer is negative, right? Rules from yesterday. And then yesterday we also touched on multiplying fractions. And this is the new part down here where we're multiplying fractions and also dividing fractions. So once again, just to get us warmed up here, let's multiply number 1. What's the answer going to be? What do you guys say? 3 over 10 is correct, right? You multiply 1 times 3, you get 3. Multiply 2 times 5, you get 10. And you can't reduce that, so that is your answer, 3/10. Moving on to number 2, everybody together. Again, on this one, we could multiply top with top, bottom with the bottom, and then try to reduce, or we could reduce first, then multiply. What do you guys want to do? It doesn't matter. Reduce first or multiply first, whatever you want. What? Reduce? All right, let's reduce. Of course, the 2 up here and the 2 down here, 2 divided by 2 is 1. So that cancels, becomes a 1. That cancels, becomes a 1 if you reduce by 2. So what's our final answer going to be? 1/3. However, we do have some signs, right? We have a negative number times a positive number. When the signs are different, your answer is what? Negative. So negative 1/3 is the correct answer there. And you didn't have to reduce first. You could have multiplied first. If you did multiply first, it would have been 2 over 6, and you could reduce 2 over 6 to that negative 1/3 anyway. Over here, this one for sure you want to multiply or reduce first? Reduce for sure. I don't want to multiply 9 times 32 and get a huge number. Forget that. It's a lot easier to be like, oh, there's a 9 up here and a 9 down there. I could reduce by 9. That becomes a 1. That becomes a 1. And not only that, the 8 and the 32, I could also reduce that. Now, I already know what I would reduce by, but what would you reduce by on the? Okay, so if you say 4, we could do that. 8 is what I would reduce by, right? 8 is the best, the biggest one. So we're going to reduce by 8. 8 divided by 8 is 1. 32 divided by 8 is 4. And what's our answer going to be? Positive 1/4, right? A negative times a negative is a positive, right? So if the signs are the same, your answer is positive. And 1 times 1 is 1 up on top, and 1 times 4 is 4 on the bottom. 1/4 is your answer. Now, let's say that you didn't reduce the 8 and the 32, okay? Let's say you didn't do that, and you actually multiplied it. Well, a negative times a negative is a positive. 8 on top, 32 on the bottom. You'd end up with, just right here on the side, 8 over 32. And then from there, you would reduce it down to 1/4. And you don't have to reduce by 8. If you wanted to, you could just divide them in half. And that would give you a 4 over 16. And then divide it in half again. And that would give you a 2 over 8. And then divide it in half again, right? And that would give you the 1/4. Many roads to the same place. Now, for the new stuff that we learned, when you're dividing by a fraction, you change the division to multiplication, and you flip the second fraction. So everybody, the first fraction is not going to change. Just rewrite it down here. This division is going to change to multiplication, and the second fraction is going to flip. So instead of 3/5, it'll be 5/3. And now we could get the answer. What's the answer going to be right there? 5/6. Excellent. 1 times 5 is 5. 2 times 3 is 6. Can't reduce it. There's your answer, 5/6. Moving on to number 2. Question. Could I cancel this 2 with that 2? No, you can't. Why not? Because it's not multiplying yet. It's kind of like, okay, you guys remember when we were adding and subtracting numbers? Like if I had 3 minus a negative 2 and I wanted to think of money, right? I wanted to think of money right there. I can't think of having or owing money yet. Why not? Because the minus negative. What do I need to do with the minus negative before thinking of money? I need to switch it, right? So you got to change that first before thinking of money. Now, right here, it's the same thing. You might see a 2 down here and a 2 up there, and you might want to cancel, but that'd be incorrect. What you have to do is whenever you have division, you have to change that division to multiplication and then flip the second fraction. Again, change the division to multiplication and flip the second fraction. First one's going to stay. Second one becomes 3 over 2. And now you could worry about canceling things out. Does anything cancel out here or reduce right here? No, nothing reduces. So we have to multiply top with the top, bottom with the bottom. Now we do know that a negative times a positive is what? A negative, okay? And the answer will be what? 3 over 4. Because 1 times 3 is 3. 2 times 2 is 4. And of course, a negative times a positive is a negative. Also, whenever you do end up with a negative fraction, you could put the negative sign out here in the front of the fraction, or you could put it even on top, but don't put it on the bottom. It just looks weird, okay? Let's try another. What do I do? Okay, we're going to begin with the division becoming multiplication, and then, yes, we flip that fraction, okay? So that first one's going to stay, negative 8 over 9. The second one becomes negative 33 over 4 instead of 4 over 33. Now, we should all know that a negative times a negative is a positive, that way you don't have to worry about the signs anymore. But do you guys really want to multiply 8 times 33 and 9 times 4? Forget that. Those are going to be huge numbers. It's better to reduce first and then multiply. So what could we reduce? 8 and the 4, absolutely. I could reduce the 8 and the 4 both by what? By 2, but even better, I could reduce both by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. You could have reduced by 2, but you'd have to continue reducing later. Anyway, how about the 9 and the 33? Could I reduce those by 2? No. Could I reduce those by 3? Actually, yeah, right? The 9 and the 33, they're both divisible by 3. So check this out. 9 divided by 3 is 3, and 33 divided by 3 is 11. So I've reduced everything possible. Now I could multiply. And up on top, well, first of all, the signs, a negative times a negative is going to be a positive. I don't have to worry about it anymore. Up on top, 2 times 11 is going to be 22. And on the bottom, 3 times 1 is going to be 3. And there's our answer, 22/3, right? And I might as well review how to change an improper fraction to a mixed number. This is going back to the 6th grade. When you do have a bigger number up on top over the bottom number that's smaller, you could do long division to get a mixed number. Let me show you that. So the top number, 22, is being divided by the bottom number, 3. How many times will 3 go into 22 without going over? 7. So we have a big giant 7 up here. 3 times 7 is 21. And when we subtract, we get a remainder of 1. Now, if I were converting this to a decimal, I would put a decimal, add a 0, drop a 0, but I don't want a decimal. I want to change to a mixed number. And how do I do the mixed number? 7 is your whole number, and this is your remainder, and the remainder always goes over the original divisor, 3. So that will be 7 and 1/3. 7 and 1/3 is the answer to 22/3. Okay, so 22/3 is really the answer, 7 and 1/3. Just in case you forgot that, you need to know it, changing an improper fraction to a mixed number. Okay, so I think we understand how to divide fractions. Why? Because it's exactly the same as multiplying fractions, super easy. If we look down here, we have the final section, exponents, all right? Let's focus in on the 2 to the 3rd equals 8. 2 is what we call the base. 3 is what we call the power or the exponent. Hopefully we remember this from previous math classes. The power tells you how many times to multiply this base with itself. So in expanded form, 2 to the 3rd, this is telling you to multiply the base with itself 3 times, is really 2 times 2 times 2. So what is really 2 times 2 times 2? 2 times 2 is 4, 4 times 2 is 8. So 2 to the 3rd is actually equal to 8, okay? 2 to the 3rd equals 8. And especially right now at the beginning, it'd be good to expand your problems before giving an answer. Now, there is a slightly confusing part to exponents. Parentheses really do make a difference. Here it is. We have -3 in parentheses to the 2nd power, and we have -3 without parentheses to the 2nd power. And notice this answer is 9, this answer is -9, okay? So let me explain what's happening here. The parentheses truly do include the negative as part of the base, okay? So when I think 2nd power, I'm really thinking this -3 times itself 2 times. So let's expand it right now together. Write down a -3 times a -3. And what is a negative times a negative? Positive. So that's why it's +9. Now, on the other hand, on the other example, notice we do not have parentheses. So in reality, what we have here is an exponent, the 3 squared. Everybody just do a little circle or something around the 3, but not including the negative, right? You see the negative is not included. Over here it is included because of the parentheses. Right here it's not included. So when I expand 3 squared, what that really is 3 times 3. And what about the negative that's in front? I'm just going to bring that down and put it in front. So this problem is really a negative 3 times a positive 3. And we know that if those signs are different, the answer is negative. So the answer is negative 9. So parentheses really do make a difference. Do you understand that? Great. Okay. So let's flip the paper over. We're continuing with the same section up here. And I even explained what I just explained right here on our notes, that when you have parentheses, you are including that negative sign. When you don't have parentheses, it's just 3 squared. There it is, 3 times 3 with the negative out here in the front. Okay. So if you understand that, what would the answer to number 1 be? Don't say negative 10. What would the answer be? It'd be negative 25. Negative 25. Once again, there are no parentheses. There's no parentheses right here. So that negative sign doesn't really belong to the 5. You got to do 5 squared first and then put the negative in front. So this 5 squared is really 5 times 5. And then you bring down that negative, just put it out in front. So what you really have is a negative 5 times a positive 5, which is negative 25. Yay? Okay. Number 2. You do have parentheses. So the negative sign is included as part of the base that you want to do the 4th power of. So that means that you're going to multiply that entire base with itself. This entire thing in parentheses, you're going to write it 4 times. This is what we call expanding. Okay. Now, before even thinking of the numeric answer, will the answer be positive or will it be negative? Positive. Okay. Now, why is that? Because we know that a negative times a negative equals a positive, right? So when these two right here, that'll pair up and become positive. These two over here will pair up and become positive, which means that everything's positive, so your answer will be positive. So now it's just a question of multiplying by 2, right? What is 2 times 2? 4 times 2, 8 times 2, 16. And we said it's going to be positive 16. So there's our answer, positive 16. Again, I want to emphasize this truth that when you're able to pair up negatives, when you're multiplying, when you're able to pair them up, that becomes positive, this becomes positive, so the whole thing's positive. I mean, technically, you could have worked it out this way. You could have said that negative 2 times negative 2 is positive 4. And then over here, negative 2 times negative 2 is positive 4. And of course, you are multiplying between the two terms, so 4 times 4 is 16. You could have worked it out that way. But the bottom line is, when you have a negative as your base inside parentheses, if you have an even number up here, you'll be able to pair them up and your answer will be positive. If you have a negative base and you have an odd number down there, then you're going to have an extra negative sign, which would take it back to a negative answer. Does that make sense? You guys asleep? No? Okay. Let me see. Let me see if it makes sense. Over here on the side, what if I had negative 1 to the 2nd power? What's my answer going to be? Positive 1. What if I had negative 1 to the 3rd power? Negative 1, right? What if I had negative 1 to the 38th power? Positive 1. You see, the idea is this. Imagine if I actually wrote negative 1 times negative 1 times negative 1 times negative 1 38 times. I'll be able to pair them all up because 38 is an even number. And you're going to end up with a bunch of positive values, so the whole thing's positive. That looks like a 7. Should be a 1. Anyway, over here, it's an odd power, which means if I go negative 1 times negative 1 times negative 1, there's going to be an extra negative, which changes it back to negative. So what if I had negative 1 to the 55th power? What's the answer going to be? Negative 1. What if I had negative 1 to the 58th power? What's that going to be? I tricked you. What about this one? I didn't put parentheses around it, huh? I didn't put parentheses around it. So what does that mean? That you got 1 to the 58th, that's just 1, and you put the negative in the front. Okay, so be careful with those details. I apologize. I probably shouldn't have done that. I'm sorry. My bad. Anyway, let me get rid of this and that and this. Delete, delete. And let's go back to our problems down here. Okay, right here we don't have parentheses. What's the answer going to be? Negative 16. That's right. The 4 squared, that's really a 4 times 4. Put that negative out in the front. That's really a negative 4 times 4, which gives you that negative 16. How about number 4? Positive 49. That's right, because you really do have negative 7 times negative 7. The negative is included as a part of the base when you expand it. How about this guy? Okay, let's actually expand it. Let's write it 5 times. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. I think that's 5. Yes, it is. Okay, now we know that an odd power, you're going to have an extra negative, which means that your whole answer is going to be negative, right? This will pair up and that'll become positive. These two will pair up, that'll become positive. But you are going to have an extra negative, which is going to take you back to a negative. So we know our answer is going to be negative, okay? Our answer will be negative, and from here on out, it's just doubling, right? What's 2 times 2? Times 2? 8 times 2? 16? 16 times 2? 32. So our answer is negative 32. Ta-da. Get it? Good. So we now have the skills to do all this assignment down here, okay? Obviously, the first part is simple adding and subtracting, thinking of money, but be careful with these guys. No, with these guys. When you have a minus negative, you have to change to plus positive even before thinking of money, okay? And then we also have multiplying, which is pretty simple. We know that a negative times a negative is a positive, or if the signs are different, the answer is negative. We also know how to multiply fractions, top with top, bottom with bottom, or you could reduce first, then multiply. And we also know how to change division to multiplication and flipping the second fraction, bringing down the first one. So what we really have here is negative 4 times 2, because 2 over 1 is just 2. So the final answer would be negative 8 right there. So we have this whole page of review. And at the last part of the page is what the last thing that we covered today, which is exponents. And we do have some that have a negative base that's included in the parentheses. And we have some that doesn't have parentheses, and that makes a big difference. So let's work on this for the rest of class. And if you wanted to check your answers, all you got to do is go to Google Classroom, and you should be able to see all your answers right there on Google Classroom so you could check as you go. Of course, it'd be totally pointless to just copy. That's no good. What you want to do is exercise that brain muscle on all these skills of adding, subtracting, multiplying, positive, negative numbers, including fractions and dividing fractions and exponents. Okay, I'm done. Let's work.